It's lesson 10, part 2, and I think we should be able to get out of here by 1 o'clock today, folks. So we've done kind of the bulk of the heavy lifting now in terms of our security model. We can sign up, we're hashing passwords, we're letting users log in, and now we've controlled fully access so that anonymous users have no ability to change anything in the database. They must register and they must log in before they're eligible to do anything. There's one other small implementation that I think we should add, which is going back to the register page that we built 2 weeks ago. So one of the things we didn't do here is there's no actual check on this page that the password values that get entered are the same when somebody signs up. I mean, we checked it on the save registration page in PHP. So if they give us 2 different passwords, we are preventing it. But we can also use a little bit of JavaScript and do a check right here on this page that they can't even submit the form if they give us, passwords like test1234 and test2222. Right now, there's nothing to prevent me from at least submitting the form. So we're going to write a simple JavaScript that we can call on the click of the, actually we can do it even on the key press event of the confirm button to make sure that the ability to register isn't even there until they've put in the same password twice. So we use a simple JavaScript for that. And then we do need to spend a little bit of time talking about SSL as well as the Owasp project. The SSL is critical. We cannot send you guys out on co-op without knowing anything about SSL. So we need to spend a little time talking about it. So we're going to create a little custom JavaScript, and then we're going to invoke it from our register page. So we've got lots of files open. We don't actually need any of these files more today. So I'm going to just close all my tabs up. And I'm going to open in my JS folder, I'm going to open up our scripts file. Whenever we're asking users to create an account and supply a password, we should always make sure that they're entering that password twice, because it's just too easy to type and then frustrating for people if they think they know their password, but they don't. So we'll create a compare passwords function. So we'll check the value here and the value there. And we'll provide a visual cue, like a message in red. We'll use the Bootstrap text danger class to display a red message when those 2 values aren't equal. And it'll also prevent the user from submitting the form if they have 2 different password values on the register page. So we'll create a couple variables here. We'll have password1, and we'll use getElementById. So this will give us the value of the password input. We'll do the exact same thing with the confirm input. Call it PW2. You can use any variable names you like. So this is going to give us the 2 values that the user entered. I then also want to reference a small element that we're going to put on the register form. We're going to add a span tag where we can display an error message. So we'll just make a reference to that. Reference span tag on register page used for showing errors, which we will add. So I'll call this PWMSG, password message. Now we're referring to the full span. There's no value property here. because these two elements are input boxes, this is just going to be a span tag. And then we can compare PW1 and PW2. So if they're not equal, we'll take our little message span and we'll set the inner text to passwords do not match. And we'll also set the class so that that text appears in red. And we can use Bootstrap for this. So we'll set the class name to text danger. And then we also want to return false. So that means when the user clicks the register button, it won't go anywhere. The form is not going to submit if we return a false. If the passwords are the same, we're going to kind of do the opposite. We'll just remove any message there. So if the passwords aren't showing, our span says passwords do not match in red. Once the user corrects the password so that they match, we're going to basically make that message disappear. So we'll just set the inner text of our span to an empty string. And we'll set the class name also just to an empty. And in this case, we'll return true. So if they match, we're going to allow the user to submit the form. So there's our complete function. There, I think we can see it all. So we'll need to do now a couple of things on our register form in order to be able to use this function. We'll need to create this element with the ID of PWMSG. And then we want to call this method both when the user's typing in the confirm box as well as when they click the register button. In both cases, we need to check that the two passwords are matching. And if they're not, we want to show this message to the user in red and stop everything else from happening. So we're not really using any PHP here, pure JavaScript. But you can start to see how the things you're doing in your JavaScript class. I know I've asked you this before. Is it Scott you guys have for client-side scripting? 1073? Or Jeremy, do you have somebody else for that course? Oh, you've got Jesse, right. You've got the JS guru, right? So you can see how we're starting to pull together some different pieces from some of your different courses where different technologies are working together. So once you have this function in your script file, open up your register form. We're going to add this password message span. And then we're going to call this method when the user's typing the password or when they click the register button. So let's open up the register page. So I'm going to scroll down. I'm actually going to, and I want to find a place to put my span. I'm going to put it right here, right after our confirm box. Let's add a span with an ID of PWMSG. So by default, that span is empty. Nothing shows up here. And in my confirm, my input type equals password, name equals confirm, I'm going to add a JavaScript event handler. So after the pattern that specifies 8 characters, uppercase, lowercase, and a digit, oops, I'll add an on key up event. So when a user finishes pressing a key, we're going to return our compare passwords. So this is going to call our method that we just wrote anytime the user finishes pressing a key inside the confirm input. I also want to call the same method on the click event of our button. So I'll add it here as well. Return compare password. And the word return is important. If we don't use return, it'll invoke the function, but the form is going to submit even if our passwords don't match. By calling return, this will evaluate whether our function returned true or false. When it returns false, the form should not submit. When it returns true, the passwords match, the user can submit the form and sign up. So this should be all the code we need. Here's our JavaScript. We've added our message span, and we're calling the method both on the key up of the confirm box as well as on the click event of our register button. So we can go to the browser now and try this out, see how it works. See if I just bring this down a little bit. So I've made changes on, basically added lines 23 and 24, and I've added the click handler to line 27. I'll shrink my browser down so you can still see the code. So I'll put in a username. I'll put in a password. Use the same password, test1234. And now I'll start typing right away. As soon as I hit a key, notice my span shows up. Passwords do not match. I'll put in test, T-E-S-T, 1, 2, 3, 4. And as soon as the passwords match, my error goes away. If I hit any other key, it comes back. When they match, error goes away. When they don't. So until the passwords match, I'll just put in 4, 5. Until they match, it just keeps me here. I can't submit the form. Right? So I'm going to have to make only when that message goes away will the form submission work. Okay, so we can use this script pretty much on any PHP. Actually, it's not even really PHP based. You could use this on any kind of site. Here's our JavaScript. And we'll just call it on the key up as well as on the click event of our button. I'll upload this to GitHub as well. So not a ton of code, mostly JavaScript. So we're adding our compare password validation. So I've uploaded this to GitHub as well. Now, does anybody have any questions at all about our little JavaScript here or our event handlers? I imagine based on what you've done for Jesse before, this is not terribly complex JavaScript. This should be within kinds of things you've already done in that class, I would assume. In fact, I assume by week 10, you've probably done much more advanced things than this. If there are no questions about the password confirmation, I'd like to leave the PHP gaming site for now. For next week, I'll show you where we're going with it. We're going to want to be able, when we are logged in, take the example from my other course, and we want to be able to include images along with our games. So when we're adding a game or editing, we'll have the ability to browse and include a photo. And when we're editing an existing game, we want to show the current photo and also be able to change it. So now my photo changes if I browse to a new photo. So we're going to grab some images of our video games, and we want to be able to attach those images onto the games when we're adding or editing. Which is also one of the requirements for assignment 2, to include file uploads like this. So this is where we're going for next week. So I want to spend some time talking about SSL. Common question that you might get asked in a co-op interview is, what is SSL? How does it work? Has anybody have any experience with implementing SSL on a website? I'm going to assume the answer is no for most, if not everybody. Does anybody know what SSL is? Okay. All right, well, I'll give you a clue. Looking at our site here, if we're looking at this page in Blackboard, we can tell from looking at my screen different kind of SSL. From looking at my screen in Blackboard, we can tell that this page in Blackboard is using SSL. How can you tell? Actually, we may have to come back to that question. SSL stands for, I'm going to put it in the chat, Secure Sockets Layer. And it used to be, for a long time, some websites used SSL and some didn't. That basically, if we had sort of a public site, like maybe it was just a static site where it was just HTML, CSS, and JavaScript, we didn't need SSL. Whereas any sites that had sort of a login or were dealing with sensitive data, they were taking credit card numbers, those sites required SSL. So yes, David, that's what the S in HTTPS indicates, that it's secure. So if we think about web traffic, let's see if I've got a graphic here. I think I do somewhere. Let's go back into lesson 1. So we looked at this in lesson 1. So here's the way most websites work, whether they're PHP or not. Right? We've got a client, could be any kind of internet-enabled device at all. It makes a request to a web server, and the web server serves back HTML. So this happens over HTTP. By default, all of the traffic exchanged between any browser and any web server is sent in plain text. So that means when you go to a website and you go to the login page, if there's no SSL, your password, username and password, are submitted to the server in plain text. If let's say that website is, an online banking site, and you say, show me my account information, the web server from your bank, by default, it'll send that HTML back just as plain text. So anybody who intercepts this traffic in between, they can easily read all of the content of those HTML requests and responses. So an SSL certificate, what it does on a website is it encrypts the request and response data. So if any hacker intercepts that traffic, the traffic is encrypted. So virtually every website you go to now, on any day, it has this HTTPS. So the S indicates the site is secured using some form of SSL. Well, not only do we see the S, but you also see this. You see this little lock symbol. So if we click it, it says our connection is secure. It says that there was a security certificate purchased by Amazon. And if we open it up, we can actually view the SSL certificate. So it tells us that our connection is encrypted. It gives us the encryption algorithm, so SHA-256 with a 128-bit key. The page you're viewing was encrypted before it was sent over the internet. Makes it difficult for unauthorized people to read the traffic. And we can actually view the encryption certificate. So it's every certificate is registered to a domain name. So if you're going to build 5 different websites for 5 clients, each one of those domains is going to need an SSL certificate. So they're registered to a particular domain, and typically they're bought for a year at a time, and you have to register them. And it describes the structure of the certificate. It has a key, and it has to be issued by a recognized certificate trust authority, which in this case is Amazon. This is critical for any website we build today. So let's look at our site on AWS for a minute. Right? So here's my PHP gaming site we've uploaded. So we have an SSL certificate, and this is part of why I've recommended you use this lamp.computerstudies domain name if you're sharing links to your work, because we have an SSL certificate verified by Let's Encrypt. So Let's Encrypt is a free service that some hosts support. However, if I load the same site through the IP address, right? This is the same website. Here I've used the domain name. Here I haven't. So what do you see about this site? What's the difference between these 2 tabs? Here's where I've used LAMP, and here's where I've used the IP address. What's different in terms of the security if you look at the top of the browser? Right, the slash, and it also says connection is not secure. Not only that, but when I go to the form, when I go to my form, I may have to upload it. Oops. Let me just quickly upload my form. Here's our PHP gaming site. Oops. So as soon as I click into Firefox, is also saying connection is not secure and your login could be compromised. So the browsers are going to give security warnings. If I go to Chrome, we're going to see the same thing or similar, right? Chrome marks it not secure. So first of all, this is not going to inspire confidence in the people coming to our site if the browsers are marking it as not secure, number one. Other thing about SSL is it actually affects search engine performance. So I've put up some resources here, and there's a good article, but a 1.5 years old. I won't read it to you, but so it explains why encryption is important. But as of a few years ago, so not only does Chrome, all browsers will mark sites that run under plain HTTP, but there's a correlation between using HTTPS and search engine rankings. So if you don't use SSL, your site is not going to perform as well. And HTTPS websites also load faster. And the faster they load, the faster they're ranking. So it's actually been 7 years that Google has factored HTTPS into its rankings. So even if there's nothing sensitive on your website, you still need an SSL certificate to optimize it. So users don't see that your site is marked as insecure, and it doesn't hurt the speed and search engine performance. So where do you get an SSL certificate if you're going to build a website? You have a couple of options. The easiest option for free is to use Let's Encrypt. So that's what we're using here in AWS. So if you're going to host any, share your links to your PHP site, you should be using the lamp.computer studies domain, and not the IP address, because the IP address isn't secure. And this lamp.computer studies is. So some hosting companies, many of them support Let's Encrypt. So here's a hosting company that I use. And for any site, if I want a free SSL certificate, I just click enable and they automatically issue me a encryption certificate. So I go to this domain, it will show as HTTPS with Let's Encrypt. So some hosts build this in automatically, but not all hosting companies support it. So I'm sure everyone's heard of these guys, right? One of the world's biggest hosting companies. But GoDaddy doesn't support Let's Encrypt. So if you're hosting a website, for example, I have some customers, they set up their own GoDaddy accounts, but then they wanted me to manage the website. So I said, okay, you need SSL for your site. And when I go here and go to security, GoDaddy SSL starts for the low price of $85 a year. That's a lot more expensive than a free one. Now, you don't pay this cost, your customer pays this, but this is an annual cost they need, and there's different levels of security. So this one, for 180, you can actually get it on 5 different domains. For this. So when you build a website, it is your responsibility to make sure you purchase an SSL certificate and set it up on your on the website. If your host supports Let's Encrypt, that's great. Otherwise, you're going to have to buy one. Some of the hosts I deal with don't support Let's Encrypt, So I've put up a link here. I often buy Ssl certificates at Namecheap. And they have 1-year certificates starting at about $10 a year. So with these, you have to buy them, you have to download the certificate, you have to put it up on the web host, and you have to ask the hosting company to install it. So these files look something like this. Show you an actual client SSL. Here's one. So here's the actual certificate file. So I bought it at Namecheap. I downloaded it. I uploaded it to the web server and asked through tech support for them to install the certificate on this domain. Okay, so this is the work you have to do if your host doesn't support Let's Encrypt, or you don't want to spend something like $85 a year, which to me is a crazy price. The one other thing about Ssl certificates is you also may have to set it up so that all requests are forced to use the SSL. So if I take out the S from this page, I'm trying to I want to load this web page now without the Ssl certificate. If I hit enter, it just redirects me back. So there's a security check making sure all requests go through the SSL. And I've put up a link here about how to force SSL for all requests on a PHP site. So if you're going to use PHP to build your own website, to build a site for a client, you can do it in PHP code. You can check the server HTTPS. If it's not set to on, you can redirect. You can also use the htaccess file and set up a rewrite rule to, again, direct all requests to use the HTTPS. So there's a few ways of doing this. If you're building a website of your own or for a customer and you ever want some help with this, please reach out to me and let me know when I can help you. But it's mandatory. We should be putting SSL on every site that we build, at least outside of school. Inside of school, you can use the SSL that we've already got set up here on the computer studies domain. Does anybody have questions about SSL at all? It is something I wanted to make you aware of because it's part of every site we publish now. And if you need help, your hosting companies will typically help you either by providing free certificates or selling them and installing them for you. We'll work with these again a bit next semester as well. So I just want 5 more minutes of your time to make you aware of one other resource that you should become familiar with. So this was recommended by a former student who now has his own application security consulting business. He's been really successful. And one of his suggestions to us was we needed to make students aware of this initiative, the project called the Owasp Top 10. I'm not testing you guys on this stuff, but it's useful knowledge for you as you're looking for work, as you're approaching your co-op semester. So this project, every few years, this group of developers, not-for-profit project, they publish the top 10 most common web application security risks. Obviously, we don't have to be security experts, but this affects what we do. So the number one vulnerability is Sql injection. And we've already talked about that within our own PHP application, where we want to make sure if users enter SQL commands into our forms, for example, that we're protecting against these kinds of attacks. They're very common. We've got broken authentication, typically around session management, which allows attackers to compromise users' accounts. Broken access control, so restrictions about what authenticated users not being properly enforced. So this relates to exactly what we did today. Cross-site scripting, which is something you may have talked about a little bit with Jesse, where a JavaScript running on one domain can hijack the site running on another domain, using components that are vulnerable and also not properly logging and monitoring. So for each one of these, they give a detailed description of how hackers exploit this, how severe it is, and they tell us, how do we prevent it? So one of the things they said is use parameters, which is why we're using that bind param method anytime we're passing values to our SQL, for example. Perform strong server-side input validation, which we're doing. And some of the other things that we're doing are in here. So this is a good reference. So for example, they say, don't do this. Don't put in a parameter directly into your SQL, because that's how somebody can attack you. So this is a useful resource. I've just linked to it here that, again, you should be familiar with, because these are the kinds of things that you might get asked about in a job interview, even as a junior developer. What do you know about, how do you go about securing or implementing basic security in a web application to protect user information? Okay, so I'm not testing you on these things, but they're things that I want you to be aware of. So I've made all these links available to you here on Blackboard. All right, for next week, please make sure that you've started on assignment 2. It's due in 2 weeks. Don't leave it right to the end. It's too much work to do over like a couple of days. So make sure you've gotten started on assignment 2. That also gives you a chance to get help if you need it. Make sure you've complete the security implementation we've done over the last couple classes. All the materials are on GitHub, and I will upload the videos to YouTube later today when they finish processing. Have a look through these links to get a little more info about SSL and Owasp. There is no review quiz this week. So the only work you should be doing is finishing off the work we did in class, if you didn't quite catch all of it, and get started on assignment 2. And next week, we're going to integrate file uploads into our PHP gaming site. Colton, can I talk about SEO? I know some about SEO. Is there something in particular you wanted to talk about, or just kind of in general, sort of some tips? Sure. You know what? That's a great question. You guys are actually going to have a full class on search in the fall, but I think it's good to talk about some of those things. It's a great question. I have a few answers, but so that I can give you a better answer, how about we start class next week with that? Where I can give you some of my thoughts about best practices, and we'll do that right at 11. So make sure you're here on time, and we can do that, cover that maybe over the start of class next week. It's a great question. I'm happy to talk about it, but I think I can do a better job. I know a little bit, but I'd prefer to prepare. So we'll do that at the start of class next week. Great question. All right, folks. So we'll wrap up early, leading into your long weekend. Okay. Have a great long weekend. Those of you who are Blue Jay fans like me, enjoy the game tomorrow. Hopefully they're 1-0. by tomorrow night, and I'll see all of you next Wednesday. Have a great week.